Most Toyota owners spend thousands fixing transmission problems that never should have happened. And the frustrating part, a $35 part available at any auto parts store could have prevented all of it. Not a gadget, not a gimmick. A real, factory-recognized upgrade that Toyota's own engineers recommend for high-stress driving conditions. This is the external transmission oil cooler with a thermostatic bypass valve. Once you understand what it does and why your stock setup is quietly working against you, you will wonder why Toyota did not include it from the factory on every single model. Let's start at the beginning. The problem nobody talks about. Your Toyota's automatic transmission generates heat, a lot of it. Under normal driving conditions, that heat is manageable. But the moment you hit stop-and-go traffic, tow anything, drive through a hot summer afternoon, or push your Toyota hard on a long highway run, transmission fluid temperatures climb fast. And when transmission fluid gets too hot, it breaks down chemically. The protective additives that keep clutch packs, planetary gears, and valve body components from grinding against each other start to fail. Once that happens, the damage is silent and cumulative. You won't feel it on Tuesday. You'll feel it at 95,000 miles when the transmission starts slipping, the shifts feel wrong, and the repair estimate comes back at $3,500 to $5,000. Toyota routes transmission fluid through the radiator to manage this heat. The fluid travels from the transmission through a steel line running along the engine bay, enters a small cooler circuit built into the lower section of the radiator, and returns cooled. On paper, that system works. In practice, it creates a problem that most Toyota owners never see coming. Why the stock radiator cooler is working against you. That built-in transmission cooler inside your radiator shares coolant space with your engine. This is called a stacked plate design, where transmission fluid and engine coolant pass near each other in separate internal channels. The purpose is to warm the transmission fluid quickly during cold starts, which protects internal components during the critical first few minutes of operation. Toyota's logic is sound. Cold, thick transmission fluid causes poor shift quality and clutch wear from increased drag. Warming it quickly using engine heat shortens the vulnerable cold start window. But here is where the system turns against you. When your engine runs hot, radiator coolant gets hot too. And because the transmission cooler sits inside that same radiator, the transmission fluid has nowhere to shed heat. Instead of being cooled, it gets heat-soaked by the very system designed to manage it. Research on transmission fluid degradation shows that fluid operating above 200 degrees Fahrenheit breaks down roughly twice as fast as fluid held below 175 degrees Fahrenheit. Every 20-degree rise in sustained temperature beyond that threshold cuts fluid service life dramatically and accelerates wear on every internal component the fluid is supposed to protect. Toyota's stock setup under heavy driving conditions can push fluid temperatures well into that danger zone. And the radiator integrated cooler simply cannot compensate when both the engine and the transmission are thermally stressed at the same time. There is a second risk that gets even less attention. If the internal walls separating coolant from transmission fluid develop a crack or pinhole, engine coolant mixes directly into the transmission. Engine coolant contains ethylene glycol. Glycol destroys transmission friction material on contact and causes rubber seals inside the transmission to swell and deform. A single internal radiator failure can contaminate the entire transmission. And by the time you notice symptoms like slipping, shuddering, or no reverse, a complete rebuild is often the only fix. Toyota has issued technical service bulletins related to this exact failure pattern across several models. The stock radiator cooler is not just a heat risk, It is a contamination risk sitting one hairline crack away from a catastrophic transmission failure. What the $35 MOD actually is, the solution is an external transmission oil cooler paired with a thermostatic bypass valve. The cooler itself is a small, finned aluminum heat exchanger that looks like a miniature radiator. It mounts in front of the main radiator, where it catches direct airflow from the grill. The thermostatic bypass valve is a temperature-sensitive component that controls where the fluid travels based on how hot it is. When transmission fluid is cold, the bypass valve keeps fluid circulating through a shorter internal loop, allowing it to warm up at the normal rate. Once fluid reaches optimal operating temperature, typically around 160 degrees Fahrenheit, the valve opens and begins routing fluid through the external cooler. Moving air passing through the aluminum fins pulls heat out efficiently before the fluid returns to the transmission to do its job again. This is not a replacement of the factory system. It works alongside it. The external cooler handles high-load cooling when temperatures rise under stress. The factory radiator circuit continues managing cold start warm-up. Both systems operate simultaneously without conflict. The thermostatic bypass valve is the critical piece that makes this work properly, because without it, an always open external cooler would overcool the transmission fluid in cold weather, causing harsh shifts, delayed engagement, and clutch wear from thick fluid dragging through tight internal clearances. The valve makes the system intelligent instead of just mechanical. The total cost for a quality external transmission oil cooler and a thermostatic bypass valve together typically runs between $30 and $45 depending on brand and your specific Toyota model. Brands like Mishimoto, Hayden, and B&M make units that fit Camry, Tacoma, RAV4, Highlander, Tundra, and Sienna models. The parts are available at AutoZone, O'Reilly, Napa, and Amazon. Some owners hesitate because modifications can complicate warranty coverage or create emissions compliance issues. This one does neither. An external transmission oil cooler is a purely mechanical thermal management addition. It does not alter engine tuning, fuel delivery, emissions hardware, or any electronic control module on the vehicle. It adds a cooling loop to the transmission fluid circuit. Nothing more. This is the same category of upgrade that Toyota installs on its own towing packages and performance trim levels. The Tacoma TRD Pro, the Tundra TRD and Platinum, and the Sequoia Towing Prep package all use enhanced transmission cooling as a factory feature. You are simply adding what Toyota already knows works to a model that did not come with it standard from the factory. CARB compliance in California is not affected. No sensors are removed or disabled. No software is modified. Smog checks will show no change. From a legal standpoint, this installation is no different from adding an engine oil cooler or replacing a factory air intake. It is a thermal management upgrade, and those carry no legal restrictions in any state in the United States. You are not voiding your powertrain warranty by adding a transmission cooler, and any dealership that tells you otherwise is not being honest with you. What heat actually does inside your transmission. Let's get specific about what sustained heat does to the components inside a Toyota automatic transmission, because understanding this is what makes the $35 investment obvious. The torque converter is the large donut-shaped fluid coupling bolted directly to the flex plate at the back of the engine. It contains a lockup clutch with a fiber friction lining similar in material to a brake pad that mechanically locks the input and output shafts together during steady highway cruising. This lockup clutch is in constant use at highway speeds, and it relies on clean, properly viscous transmission fluid for both lubrication and cooling. When fluid degrades from heat, that friction lining begins glazing. A glazed lockup clutch slips under load, generates additional heat, and eventually causes shudder that many Toyota owners feel between 40 and 55 miles per hour. That shudder is commonly misdiagnosed as a tire balance issue, a drive shaft vibration, or an engine misfire. In reality, it is a heat-damaged torque converter lockup clutch telling you the transmission fluid failed it. The valve body sits at the bottom of the transmission case and is the hydraulic brain of the entire automatic transmission. It contains a maze of precisely machined fluid passages and a series of electronically controlled solenoids that regulate shift timing, line pressure, and torque converter engagement. These passages are machined to tolerances measured in thousandths of an inch. Degraded heat-broken transmission fluid leaves varnish deposits in those passages over time. Varnish is essentially cooked fluid residue, and it acts like a partial blockage in each passage it coats. Restricted flow causes delayed shifts, harsh engagement, erratic gear selection, and eventually solenoid failure from inadequate lubrication. Replacing a single transmission shift solenoid at a dealership typically costs $300 to $700. A full valve body replacement runs $800 to $1,500 in parts and labor, all of it preventable. The clutch packs are stacked sets of alternating steel plates and friction-lined discs inside the transmission that create each forward and reverse gear ratio when hydraulically clamped together. They engage and release hundreds of times during every drive. Each engagement generates a small amount of heat and relies on a stable fluid film to prevent direct metal-to-metal contact. When transmission fluid loses viscosity from thermal breakdown, that protective film collapses under load. Steel contacts friction material directly. The friction discs wear faster, the steel plates score, and eventually the clutch pack fails to fully engage under load. The transmission begins slipping. The repair at that point is no longer a fluid change, it is a rebuild. Every one of these failures shares the same origin point. It is sustained high fluid temperature that the stock cooling system was not equipped to handle under real-world driving conditions. The Toyota community already figured this out. If you spend time in Tacoma owner forums, particularly among drivers who tow trailers, haul equipment, or live in desert climates like Arizona, Nevada, or Texas, external transmission coolers have been standard preventive maintenance for over a decade. Owners running the 5-speed automatic in second and third generation Tacomas consistently report that transmission fluid temperatures under towing load exceed safe limits with the stock setup. After installing an external cooler with a bypass valve, those same owners report fluid temperatures running 30 to 50 degrees lower under identical load and weather conditions. That temperature difference is not minor. It is the margin between fluid that survives 60,000 miles and fluid that degrades in 30,000. It is the margin between a transmission that reaches 200,000 miles and one that requires a rebuild at 110,000. Tundra owners towing fifth wheels, Highlander owners running hot freeway commutes with full passenger loads, and Sienna owners doing long summer road trips with the air conditioning maxed out all report the same pattern. The stock setup gets the job done under light conditions. Under real American driving, it runs too hot too often. The 8-speed automatic found in newer RAV4 and Camry models is particularly sensitive to thermal stress under urban driving conditions. Frequent low-speed gear changes in stop-and-go traffic generate heat without the sustained airflow that highway speeds provide. These transmissions run noticeably cooler with an external cooler in place, and the shift quality stays consistent over more miles compared to stock. What this does to your fluid and your service intervals. Transmission fluid is the single most neglected service item on most Toyotas. Toyota's published maintenance schedules on many models stretch fluid change intervals to 60,000 miles under what the manual calls normal driving conditions. Some owners encounter the phrase lifetime fluid on certain models and interpret it as meaning the fluid never needs attention. Neither interpretation was designed to account for heat-degraded fluid on a vehicle doing real American driving. When an external cooler holds transmission fluid temperatures consistently in the 160 to 175 degrees Fahrenheit range, instead of allowing repeated spikes toward 200 degrees and beyond, the fluid chemistry stays stable significantly longer. The antioxidant additives, the anti-wear friction modifiers, and the seal conditioners packed into a quality full synthetic automatic transmission fluid are engineered to work within a specific temperature window. Keep them in that window, and they do exactly what they were formulated to do. Push them past it repeatedly, and additive depletion accelerates at a rate no published service interval was ever designed to account for. Owners who install external transmission coolers and then send used fluid samples to oil analysis labs at their service intervals consistently find lower oxidation numbers, lower total acid content, and lower wear metal concentrations compared to samples taken before installation under the same driving conditions. Lower oxidation means cleaner valve body passages. Lower wear metals mean healthier clutch packs and planetary gear sets. Cleaner fluid across every component means longer service life across every component. The real cost comparison. Here is the number that puts everything in perspective. A quality external transmission oil cooler and thermostatic bypass valve costs between $30 and $45. Professional installation at an independent shop typically adds $80 to $150 in labor, though many Toyota owners with basic mechanical confidence install it themselves in under 2 hours using hand tools. The total investment lands somewhere between $35 and $200, depending on how you approach it. A torque converter replacement on a Toyota Camry or RAV4 at a dealership runs $900 to $1,500 in parts and labor. A valve body replacement runs $800 to $1,500. A complete automatic transmission rebuild at a dealership currently averages $3,200 to $4,800 on most Toyota models. A remanufactured transmission with installation runs $2,800 to $4,200. A transmission failure that happens out of warranty on a vehicle you plan to keep for another 100,000 miles is not just expensive. It is the kind of repair that makes people sell the car. Every dollar of that repair bill traces back to one cause. The transmission ran hot for too long on too many drives without adequate cooling. A $35 part was the only thing standing between reliability and that repair bill. And it was available at the auto parts store the whole time. The honest bottom line: Toyota builds genuinely durable transmissions. U151E, A750F, AB60F, and the direct shift CVT in newer Corollas. These units are engineered to last, but they were engineered to last under the thermal assumptions Toyota's design team used during development. Those assumptions did not fully account for 110 degrees Fahrenheit Phoenix summers in bumper-to-bumper traffic. They did not account for towing a boat every weekend through the Texas Hill Country in August. They did not account for the 200,000-mile and beyond ownership cycles that American Toyota drivers now expect from their vehicles. An external transmission oil cooler with a thermostatic bypass valve does not change what your Toyota is. It changes the conditions under which your Toyota has to perform. Lower sustained temperatures, stable fluid chemistry, protected clutch packs, valve body passages, and torque converter friction material. That is not a trick or a shortcut. That is basic thermal engineering applied to a system that was already operating close to its limits under real-world American driving conditions. The transmission that fails at 95,000 miles was not a defective transmission. It was a transmission that ran too hot for too long because a $35 part was never installed. That is the only difference between the Toyota that makes it to 250,000 miles and the one that does not. If you are enjoying this video, consider watching the next one. In it, I share the exact transmission fluid Toyota technicians use to bring aging transmissions back from the edge.